This tutorial will explain how to use the rule of transposition in the ProofLab. Okay, so here we have this proof that's almost done. We're trying on line 8 to get from P arrow M to the formula M or not P. So we've performed the definition of the conditional on this to give us not P or M. But then we'd have to perform commutivity on it, which is not a problem. We could totally do that. But maybe there's another way we could do this proof. So let's try that out. So what if we performed transposition on line 8? Then that would switch to the order 2. So if we perform transitivity on it, so we're going to click the conditional, then it's not transitivity. That's why I don't like calling it trans. I would rather it was contraposition, which is usually abbreviated contra, which is a weird abbreviation, or contra, which is also kind of weird. But anyway, we're stuck with trans. It's transposition. I knew I would say transitivity at some point. This is not the property of transitivity. That's hypothetical syllogism. So I apologize. I'll try not to do that again. Okay, so we click on the conditional, we click on the rule of transposition, and it shows us that what we'll get is not M or not P. So we click apply. And now, when we perform the rule of definition of the conditional, everything's going to be in the right order. So we click on that rule, we click on this. Okay, so this is going to be a little problematic because what we get is not exactly what we want. We get not M or not P, and that's correct. That's exactly what you should do according to the form of the definition of the conditional, because when you're moving from the conditional form to the disjunctive form, the right disjunct of your new disjunction that you're creating will be the same as the consequent of the conditional you started from. But the left disjunct will be the negation of the antecedent of the conditional you're starting from. So that's correct according to the form. That's exactly how I want you to do it. I don't want you to suppress that double negation. And then what you would do if you were doing this by hand is then you would just apply double negation to this and you'd be good to go. However, as we've already seen in the tutorial, actually we haven't seen this, but we've seen it in other, I haven't done a tutorial on double negation. You will see in the tutorial on double negation that you can't apply double negation inside lines, but we've seen that with other rules that you can't apply double negation inside a line. So we know this isn't going to work. Sad. So actually this whole plan isn't going to work, but it served as a introduction to how to do transposition. I said it right that time. Okay. Let's see one more thing with transposition. So we should be able to apply transposition to this conditional as well. And what we should get is our original statement back. However, sadly no. Not in the ProofLab. For some reason it's treating transposition as if it's a one-way rule, when it really isn't. It's valid either direction. And this is really problematic because, okay, so you could do that. That's a perfectly valid application of transposition, and you could do that. And then you could apply double negation to the insides of the lines, and you could get back P arrow M, except that you can't in the ProofLab. So what this means is that if you have some formula that has a negated antecedent or a negated consequent, you had better want there to be two negations on what you end up with, because that's how it's going to be. You can't go the other direction in the ProofLab. Now, when you're doing proofs for me, that's totally fine. You could go from line 9 straight to P arrow M, and that would be totally fine. You could also go from line 9 to line 10, fine, and then line 11 could be P arrow M by double negation. That's all totally fine. But it's going to be problematic in the ProofLab. If you need to get from not M, arrow, not P, you're going to need to do that via a reductio variant on arrow in strategy. That's what it's going to take. You're going to have to do it the hard way, which is ridiculous. And you wouldn't even be able to do it now, because if you wanted it for some reason, which you don't, because you already have P arrow M. This is just for demonstration purposes. Because you don't have the basic rules, or the rules requiring assumptions in this proof module. Because they want you to focus on the derived rules. I mean, that's the point. You don't need these rules. You don't need the basic rules or the all these rules that are grayed out. You don't need them to complete this proof. And you see, as you saw before, we were one step away from completing it before by commutation. So this is all just demonstration purposes, really. But it's a little annoying. But just a heads up, it's a little annoying. So this is how it works. I didn't write it. And it doesn't seem like that would be that hard to program. I mean, I guess they would probably need to have 2 versions of transposition, maybe. Say, oh, I'm doing the version with the negations on it. Or, I'm doing the unnegated version. How hard would that be? Sorry about that.